Hey, thought I would try another integral today. We have one here. This one's from MIT 2020, problem 17. We have the integral of 6 to the 4th x tan x over 6 to the 4th x plus 4 dx. Okay, I think there's quite a few ways to do this, and what I want to do is start off with a straightforward approach. I think what we'll end up doing is 1.5 methods or... Okay, so let's just start with this straightforward thing and see how it goes. Now, because we have secant and tangent in an integral, those work well together. So that's because the integral of tangent is secant squared. The integral of secant is secant times tangent. First, I was looking to maybe do a substitution like for tangent, but I think it's going to work better if we substitute for secant. So let's try a u substitution, and we'll call our u equal to secant of x. Then again, the derivative for that, our du, is going to be secant x tan x dx. And before I do this substitution, I just like to clean it up a little bit, and I'll rewrite this numerator. Instead of having it like this, I'm going to write it as secant cubed x, and then we'll have secant x tan x dx. Just noticing secant cubed times secant gets us back to secant of the fourth, and then all of this right here is our du value. And now I'll just make this substitution. So here, this secant cubed is going to be u cubed. This again is our du. Denominator, we're going to have this secant fourth is u to the fourth plus 4. Okay, and this isn't looking so bad over here, but I think what we need to do is just another substitution. So I'm going to substitute for this whole denominator. I'm going to call this, we already used u, so I'm going to use t. So we'll say t is u to the fourth plus 4. Take the derivative, and our dt is going to be 4 u cubed du. And then just notice this is really similar to what we have, but what I need to do, I don't have to, but let's just do it this way. I can kind of add in or multiply in a 4 and just divide by a 4 so that we're not changing it. And now we'll do this second substitution, and we're going to have our 1/4 out front. We'll have our dt in the numerator, and here we'll have just t. Okay, let's just do this integral now. So we're going to have 1/4. This integral is natural log absolute value of t. But in a second, we're going to see that when we substitute back to u, we're not going to need the absolute value because this is an even power. So this term is always going to be positive, and that's going to allow us to drop the absolute value and write this as absolute value natural log of u to the fourth plus 4 plus c. So finally, let's get back to x, remembering that u is secant x. So for our final solution, we're going to have 1/4 natural log secant to the fourth x plus 4 plus c. Okay, now remember at the beginning of the video, I said maybe I want to do 1.5 methods. Well, the thing about this, whenever you do two substitutions like we did here, we substituted to u and then we substituted to t, well, that can be combined into one substitution. Now, you don't have to combine them to two. There's nothing wrong with doing 2 substitutions or 3 substitutions. Now, notice in our solution that we actually have the denominator right here. So what we could have done is, instead of doing these 2 substitutions, we could have just done 1 substitution and made u our denominator right away. So the only reason I show this kind of longer method is just because it might not be apparent right away that you could do that u substitution for the denominator, but it's going to be a little quicker. So let's just do it that way really quick. Okay, so for my method 1.5, we're going to just do this u substitution for the whole denominator right off the bat, and let's see how this works out. So what I'm going to do is, we got our u, let's take our derivative. So for du, we're going to use power rule on this. So we're going to have 4 secant x cubed, secant cubed x, but then we need the chain rule, which is going to give us a secant x tan x, and then the derivative of 4, of course, is 0. And we'll just have a dx on the end. But of course, we can clean this up a little bit. Secant cubed times secant x is going to be secant to the fourth x, and we'll have our tan x, and don't forget this 4. And so this is pretty much what we have in the numerator. If we just add we'll multiply by a 4 and a 1/4. Okay, so doing this substitution, we're going to have just 1/4 du in the numerator and the whole denominator being u. Integrating this, we're going to have 1/4 natural log, but I'm just going to drop that absolute value right away because I know what's going on. We have this for u, so I'm just going to put this back, and we have the same solution in like 1 step. That's it. Thanks for watching. Please like and subscribe. Have a great day.